let's say, the region enclosed by the curves y equals x and y equals x squared is rotated about the x-axis. Find the volume of the resulting solid. So look at the functions that we're talking about here. Y equals x, y equals x squared. You want to find their intersection points. I think we already did that when we did area between curves. You find the intersection points and draw your region. So here we go. They intersect at x equals 0 and x equals 1. That one's a straight line. And then this one is down here, your parabola. So this is the region that I'm talking about, this little shape here. And I'm rotating it about what? X-axis. So I want to rotate it here. So let me take my strip, my little strip in my region. So let me put that in here. That we're going to use to determine the radius. Let me put it. I'll put it right here. So this strip looks a little bit different from the strips we looked at before. In the previous examples, my little rectangular strips always touched where I was rotating about. They always touched either the x-axis for the first one, or in the second one, they touched the y-axis. But here, if you look, my strip doesn't fully come all the way down to my rotation line. So when I rotate this around, what that means is I'm going to have a hole on the inside. I rotate it around, you're going to have a hole on the inside. So instead of that nice disc, what you're getting is essentially you're going to get this disc, but it's going to have a hole in the middle. Okay, and this point here represents my rotation line, just so you know. And you're getting something that looks like this, which is something called a washer. Like you would have on a nut and a bolt, a washer. It's got a hole in the middle. It's like a disc but with a hole in the middle. So what we want to do is we want to find again, I need the area, A of x, of my cross section. So I want to find the area of this washer. And what you can really do, if you look at this, it's made up of this bigger circle, right? And then this smaller circle. So I can find the area of the bigger circle, but I've counted too much area, right? I've counted this inside area when I didn't want to. So then I'm just going to subtract off that inside area. Okay, so you can think of this as maybe I'll write pi big R squared minus pi little r squared. And this little r is the radius of the inner circle, and this big R is my radius of my outer circle. So let's see if I can find big R. Big R, it comes from one of these two functions, and it's really the function that's further away from my rotation line. And that's the line. The line is further away from my rotation line. So big R is y for the line function, which is x. Because we're using, so for this one, we're using the equation y equals x. Okay. So I can now plug in pi x squared. And then what's my little r? It comes from the one that was closer to my rotation line. So little r is going to still be y, but now I'm using that other function, which was x squared. I'm using the function y equals x squared. So little r is going to be x squared. Minus pi x squared squared. Okay. So it comes from this idea of having an inner and an outer radius, essentially, is what you're doing. And you're subtracting this first term, pi x squared, computes the whole area of this, if it was a disk. And so I need to subtract off the inside part that I'm missing, which is the second term here, subtracting off the inner part of that washer that I'm missing. Okay. And after you know a of x, then you're pretty much set to go on this problem. You just have to put in an integral pi x squared minus pi x to the fourth. And I need to put on bounds. What number should I put on the bounds here?
0 and 1.
0 and 1. X went between 0 and 1. Okay.
Can you explain again why the little r is equal to x?
Yeah. So I said this, there was a dot in the middle of this circle, or yeah, in the middle of the circle, which represents this line. Okay? And so this little r here, it's represented on the graph by this part here. That's my little r. And so that little r is the height of my function. It's y, but the function, this bottom function is x squared. Okay? And then my big R here on my graph would be represented by this distance there. That's my big R. Is that good? Any other questions? The formula is very much the same, but you need to make sure, do I have a disc or do I have a washer? Is there a hole in the middle or not? Because if there's not a hole, it's a disc, you're going to go pi r squared. If there is a hole, it's a washer, and you do pi big R squared minus pi little r squared.